So hello everyone. So in this lecture we will solve this problem. And the problem is, let E is a subset of R which is non-empty and bounded above. R is the set of rational real numbers. If alpha is a real number which is an upper bound of this set capital E, and if alpha is inside the set E, then show that alpha is the least upper bound or the supremum of the set capital E. Okay. So it is automatically given that alpha is an upper bound. So to prove that alpha is the least upper bound, it is enough to prove that if I take any beta which is less than alpha, then beta cannot be an upper bound of P, right? Because to prove that something is a supremum, we need to prove two things. First thing is that alpha is an upper bound, which is already given here, so I don't need to prove that. Second thing is what I told. So let beta is less than alpha. If we can say that or prove that beta is not an upper bound of E, then we are done, right? So claim beta is not an upper bound of E. But it cannot be an upper bound of E since alpha is itself inside the set E and beta is less than alpha. Alpha is inside the set capital E. So beta is not an upper bound of P, because every upper bound, if beta is an upper bound, beta has to be bigger than equal to alpha, because alpha belongs to E. In fact, beta has to be bigger than equal to every element of the set E, right? But alpha is inside the set E, so beta is not an upper bound of E. So my alpha is nothing but the supremum of the set capital E, or the least upper bound of the set capital E. In the next question, I will calculate this. So find the supremum and infimum of the set n by such that m belongs to the set of integer and n belongs to the set of natural numbers. Okay. So I will try to find the supremum and infimum, okay, of this set. Okay. So the solution. So in the first part, let's say step 1, we'll find the supremum. Okay. What to do to find this? Observe that this n by this, take any element, all the elements of this set looks like this. This is always less than equal to 1, right? And that implies that 1 is an upper bound of this set. Let's say this is S, is defined by S. Yes. Now take m equals to 0. Then you get an element of this set looks like this for any n belongs to H is nothing but 1, and this belongs to S, right? Because all the elements looks like n by mod m plus n. So in particular I can take m equals to 0, so I get this. So 1 belongs to S. Now I use this result. This set S is bounded above, right? It's non-empty, bounded above. If alpha is an upper bound, so 1 is an upper bound and 1 belongs to E. So then alpha is the supreme. So in our case here, alpha is 1, right? Alpha is 1. It's an upper bound and it's inside the set. So by the previous result, supremum of S is 1, right? Yes. Okay. Now in the step 2, we'll find find the infimum. So for any n belongs to n and m belongs to z, we have this, right? Because small n is positive and mod of m plus small n is also positive, right? Yeah, positive. We need to check what is the infimum. So 0 is a lower bound, right? So what is the infimum? Okay. So we'll fix our small n and we'll make our mod m as large as possible. Okay. So then we'll see that this quantity will go to 0, right? 0 is a lower bound. Okay. So what I'm saying that hence 0 is a lower bound. Okay. Moreover, for any epsilon bigger than 0, we can choose mod of m large enough so that small n by this plus this is less than epsilon, right? Okay. So whatever, so if 0 is a lower bound and I don't know whether 0 is the greatest lower bound or not, so I will take any epsilon which is positive. Maybe this is the greatest lower bound, but I can find, actually I'm saying that I have something like this and this belongs to S. And this says that epsilon cannot be a lower bound because epsilon is bigger than this element of the set S, right? So supremum of so the infimum of this S is 0. Okay, so supremum is 1 and infimum is 0. Okay, so here we stop.